Hello everyone, I'm Teacher Yi. Welcome back to our YouTube channel. Today, I'd like to talk about a challenging question which is about the river flow problem. Now, let's have a look. So from the question, we know that it took 3.3 hours for the ship to travel from port A downstream to port B along the river, then return upstream to port A. If the distance traveled during the first, second, and the third hour can exactly form an arithmetic sequence, and the current speed is 3 km per hour, we are asked to find the distance between port A and port B. So everyone, you can see that this is kind of our question, which is also a distance problem, right? So we can try to draw the routing line. So in this case, we say that we have port A to port B, and we know that the ship will travel from port A to port B downstream. And then it will travel from port B to port A upstream. And we say that it took a total of 3.3 hours. And then in this case, we also say that the first, second, and the third hour, they form an arithmetic sequence. So everyone, what does it mean by the arithmetic sequence? Alright, so for example, we say that 1, 4, 7. So you can see that the difference between this number, 1 to 4 is 3, 4 to 7 is also 3. We call this the arithmetic sequence. The difference between the consecutive number, they are the same. And also, let's say 14, 12, 10. You can see that the number minus 2, minus 2. The difference is also the same. We call this the arithmetic sequence. So everyone, we know that the first, the second, and the third hour, they are the arithmetic sequence. But we know that the ship will go downstream and it will go upstream. So how do we know that in each of these hours, the ship will go up or go down? Let's look at the first hour. So what do you think the ship will go upstream or going downstream? What is the possible situation here? Everyone, you can see that the ship will go from A to B, going downstream at first, right? So definitely it should start going downstream. But guys, is there any other possible situation here? Is there any other? Oh, it can also go downstream and upstream. But is it possible right here? If it goes downstream and upstream, what will happen? You see that the second hour will go upstream. The third hour will also go upstream. And in this case, is this an arithmetic sequence? Oh, you can see that. Going up. These 2 hours, the speed will be the same. The time, they are the same. The distance, they are the same. So it is not an arithmetic sequence. So we say that the ship cannot go down and go up in the first hour. So it must be going downstream. Now for the second hour, what will be the possible situation here? Can it be just going down? It is just going down. The first and the second hour, both of it will going down. This is not an arithmetic sequence. Can it be going up? If it is going up, then the second and the third hour will be both going up and also not an arithmetic sequence. So we know that the second hour must be going down and up at the same hour. Alright, and then how about the third hour? Oh, it must be going up. So now we know that the first hour, we're going down by 1 hour. The third hour, we're going up by 1 hour. How about the second hour? How do I know that going down and going up is how many hours? How do we find it? We want to make sure that it's an arithmetic sequence, right? So now, let me give you an example here. If I have 0.1 hour, 0.9 hour going up, is this an arithmetic sequence? So we can try to calculate the difference. We find the difference for the first and the second hour. You see that going down 1 hour minus we going down 0.1 hour. So you have going down 0.9 hour. Then minus by going up 0.9 hour. So this is the difference between the first and the second hour. Now let's look at the second minus with the third hour. So in this case, we have going down by 0.1 hour, and the third hour, there is nothing going down. So it is down by 0.1 hour. Then we have going up 0.9 hour, minus with going up by 1 hour. Then we will have minus 0.1 hour going up. You see that in this case, both of the difference, they are not the same. So we say that this is not an arithmetic sequence. So how do we find the arithmetic sequence? So actually, it is just 0.5 hour, 0.5 hour. Let's try to see if this is an arithmetic sequence. We can find the difference between the first and second hour. You see that going down 1 hour minus with going down 0.5 hour, we have down by 0.5 hour. And then there is nothing going out here, then we minus by going up 0.5 hour. Then the second hour minus with the third hour. You see that going down by 0.5 hour minus with nothing going down here. So we have down 0.5 hour. Then going out 0.5 hour minus with going out 1 hour. Then you will have minus up 0.5 hour. So everyone can see that in this case, they have the same difference. So we have find our time now. So now we know that the total time it is 3.3 hours. So what will be the time going down? It will just be 1.5 hours. How about the time going up? What is the total? It will be 1.8 hours. Because the total time it is 3.3 hours. So the remaining time other than the first 3 hours will all be going up, everyone. Now that we have find the time going up and going down, let's try to find the distance. But everyone, in this case, do we know about the speed of the ship? Do we know about that? We do not know about it, right? So in this case, we can first try to denote it as A. So we say that A is equal to the speed of the ship. And in this case, what is the relationship of going downstream and going upstream in terms of the distance? What can we say about that? The distance, they must be the same, right? Going A to B, going B to A, they must be the same. So to find the distance, we can use the time multiplied by the speed. In this case, we have going downstream 1.5 hours. We'll need to multiply by the speed. So everyone, in this case, we say that the speed of the ship is A. It is just A. In this case, because it is going downstream, we still have to sum up with the speed of the water, which is 3 km per hour. So it will be A plus 3. And then for going upstream, we use 1.8 multiplied by the speed, which is the speed of the ship minus with the speed of the water, A minus 3. So we just say that the distance, they are the same. So we know that these two parts, they are equal. So now we just have to solve the equation to find what is A. So in this case, we have 1.5A plus 4.5, which is equal to 1.8A minus 5.4. Then you can see that 4.5 and minus 1.4, we have 9.9. Then 1.5A, 1.8A, we have 0.38. Then now, since we are trying to find A, I can move A to the left. So we have 0.38 equal to 9.9. And finally, you'll see that A equal to 33. In this case, now that we have found what is A, we can try to find the distance. You can either calculate going downstream or you can calculate going upstream. In this case, let's try to use going downstream. So we have 1.5 multiplied by 33 plus 3, which is equal to 54 kilometer. And this is our final answer. So everyone, let's try to summarize what we have learned from this question. So we know that we have the arithmetic sequence. So arithmetic sequence means that the difference between the consecutive number, they must be the same. So it can either you use the first minus with the second number, or you can use the second number minus with the first number. It can be different type of the difference here. And then we say that the river flow problem. The first thing, if it is going downstream, this is the speed going downstream. We say that if some object is going downstream, then the speed of the object will be the speed itself plus with the speed of the water. If it is going upstream, then the speed of the object will be the speed itself minus with the speed of the water. This is what we know from the river flow problem. Alright, so now you can try to do this practice question and you can try to leave your answer at the comment section below. Right, so now you can join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.